All right, we have been talking about, we're going to review really quick. It says in this chapter, we've considered 6 ways in which the relationship between two quantities can be represented. In words, a mapping or arrow diagram, a table of values, an equation, a set of ordered pairs, and a graph. These are all the ways to show a relation between two things. In a relation, each element of the domain, in other words, the input, what else goes with input? X, independent, horizontal axis. In a relation, each element of the domain or the input or the x's is related to an element or elements of the range, which is the output. We put something in and we get something out. In this lesson, we will study a special type of relation called a function. Okay, this is a special type of relation, and we're going to call them functions. Okay, so if we look at 1, 4, 9, and 16 as the things that are going into the machine, and we get out 1, 2, 3, and 4. Is 1 a multiple of 1? Is 4 a multiple of 1 and 2? Would you say? So this says it's a multiple of. So I'm asking you right now, is 4 a multiple of 1 and of 2?
Yep.
Yes. 9 is a multiple of which of the other things? 1 and 3. 16, on the other hand, is a multiple of what numbers? 2
And 1.
and 4 and 1. All right? Let's talk about 1, 4, 9, and 16, and let's talk about if I said that the machine is a square of, if I said we're talking about the relationship that something is a square of it, then 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, and 16 would be the square of 4. If I asked you to complete the ordered pairs for this, I would have 1, 1, 4, 1. Watch this. 4, 2. What's next? 9, 1. What else? 9, 3. What's the next one? 16 and 1. 16 and 2. And 16 and 4, correct? I don't need you to talk. Actually, not at all, because I don't think you have a clue with what I'm doing up here. Okay, what is number 2? If I put these in ordered pairs over here on this side, what would you say?
1 and 1.
Yep. 1 and 1, 4 and 2, 9 and 3, 16 and 4. Now, one of these relations is going to be a function, and one is not. If I went to plot these points on the grid, watch what would happen. I would plot the point 1 and 1, 4 and 1, 4 and 2, 9 and 1, 9 and 3, 16 and 1, 16 and 2, 16 and 4. See it? This is not a relation, by the way. Sorry. This is not a function. So relation, it's a multiple of them. We can talk about it, but it's not a function. This is a function. 1 and 1, 4 and 2, 9 and 3, 16 and 4. I want you to write no here and yes here. Let's keep looking and see if we can figure out what is it that makes something a function. Is there a way to tell? Turn the page. Here's the definition. A function, a functional relation or a function is a special type of relation in which, get this, each element of the domain, so each x value is related to exactly one element of the range. Okay, now Joey, this takes thought. Listen, every element of the x over here on this side is related to only one thing in the range. If that is true, it is a function. That's why this first example over here with the is a multiple of, this is not a function. Do you see how there are more arrows leaving? 16 actually is related to 3 different things. That is a relationship, but it is not a function. It doesn't function, okay? Notice how this one over here was a yes. That's because each x value only goes to one y value. That's what it takes to be a function. Everything in the input only has one output. When you put something in, you only get one thing out. If you get more than one thing, we have trouble. It's not a function. Okay. So can I just write this all down at one time? For every x value, there is only one y value. That's what it takes to be a function. For every x, you only have one y. So if an x value is 3 and 7, then you can't have 3 and -2. It's not allowed. See how the x value had two different y values? That can't happen. If you give me an x, I better be only able to find one y value. So look down here. I want you to write these on there. This is a yes. This is a yes. This is a no. This is a no. These are not functions. They're relations, but they're not functions. Do you see that for every value in graph A, no matter where, pick an x value for A, anything between 1 and negative, you're going by threes. By -4 to 4, pick one. 4. If I look at this graph A and I look at 4, that would put me here, right? That would put me here. And if I go up, is there only one y value? Yeah, it's right about there. See it? Pick a different value between -4 and 4. 2. If I look at 2, I go to here on my x-axis, and when I go up, there's only one y value. There's no other place on here. If I look at 2 here, well, let's look at 0. If I look at graph C and you tell me 0, I have a value here and a value here. Not allowed. That's not a function. If I look at, say, a value on graph D, like 4, so if this is 0, 0 here, I go 1, 2, 3, 4. Look, I've got a value option to go there or a value of an option to go there. For the same x, I've got two different places to go. I don't know where to go. It's not a function. There's a line test here. If you can draw one vertical line everywhere, no matter where you draw it, and it only touches one spot, the relation is a function. We say, yes, it's a function.
Okay, so it doesn't matter if there's multiple y's or one.
That's okay. No. What? Okay. I can do 3 and 7. Here's what Noah's talking about. I can go 3 and 7 and -2 and 7. That's allowed. That's allowed. Yes. But for every x, whatever I put in, I can't be confused. I can't go, I'm going to put in a 3 and I can either get a 7 or a 2. Nope, not a function, not allowed. If I put something in, I have to get one answer. Only one. Okay, so graph B, no matter where you draw your vertical line, no matter what x value you put in, you only get one y value. That's a function. But look at C. Nope. Not a function. That's called the vertical line test. And the vertical line test states, if you draw a vertical line and it touches the graph in more than one spot, it is not a function. Turn the page. We're going to write that down, I think, somewhere. Hopefully. Come on. Refresh. Or not. I guess you have to go side. No. Okay, here's the vertical line test. Turn the page. In the middle of the next page, it says vertical line test. That's what we're doing. So it says, if every vertical line drawn on the domain, I'm reading right here, follow along. Read right here. Okay, I'll read along. If every vertical line drawn on the domain of the relation intersects the graph exactly once, then the relation is a function. You with me? If any vertical line intersects the graph more than once, it is not a function. Because that means there would be two different outputs for the same input. So then it says, okay, let's go try it. Determine which of the following are functions. Class example number 3. 5, 8, 6, 7, -5, 3, 2, 3, 6, 8. Anybody want to decide, guess yes or no right now?
I say yes.
Here's what I would do. I get kind of confused sometimes when I do this. Okay, not really, but pretending. So I do this. I give myself a quick graph, and I just quickly throw those numbers up there. If I plot 5 and 8, I don't even care what it is. It's up there.
Oh, that's
Where is 6, 7? Oh, a little beyond, not quite so high. Where's negative 5, 3? Oh, back over here, up a little bit. How about 2, 3? Oh, okay, like there. And where is 6, 8? Uh-oh, 6, 8. Wouldn't that lie right above 6, 7? We're in trouble. If I draw a vertical line, touches it in 2 places, shucks. The answer is no. You know what I mean? So just quickly throw your points up on a graph. It doesn't have to be pretty, doesn't have to be exact, but you'll figure out that whether it does or doesn't. Let's go part B. Okay, if I throw my little points up on part B, I go 3 and 3. I don't know exactly. I'm going to just go there. 2 and 3 would be not quite so far, same height. 4 and 5, a little beyond, a little higher. And negative 3 and 2. Does it pass a vertical line test?
Yep.
Yes. How about this one? Does A only get one answer? P. Does B only get one answer? Does C only get one answer?
yes.
Yes. Every input can only have one output. Okay, how about D? Is that is it going to pass the vertical line test? No. See, there's a couple places. Doesn't. Well, I guess that's the only place. Doesn't pass. For the same X value, there are 2 different Y values. Okay, how about this one? How about in words? The relation connecting the provinces and the territories of Canada. Think provinces and territories, okay? Alberta, BC, Quebec, none of it. And their capital cities. For every province or territory, does it have its own capital city?
Yes.
Yes. None of them have, like if you say the capital of Alberta, you only get one answer. What is the capital of Alberta? Good. Okay.
What was it?
Edmonton is the capital of Alberta. What is if I say the capital of Ontario, what are you going to tell me?
I was gonna say Montreal. It's Ottawa, Canada.
Toronto is the capital city of Ontario. I'm being recorded. I hope that's right. I'm quite sure. Yeah. Ottawa is the capital of Canada. Okay. How about letter F? Is that going to be a function?
No.
Does it pass the vertical line test?
Oh,
Yes, it does.
Oh, that's
Yes. How about letter G? No. Boom, right there. Doesn't pass. This is a no. Okay, turn the page. Did I just repeat the page? It did. Is that it? I'm missing a page.
Function as mapping.
Okay, I have to press stop here because I don't have that page, and I'm gonna draw it on the board, I guess.